Just north of the Martian equator lies a 45 kilometers wide impact crater that scientists believe may have been the site of an ancient lake. Here at Jezero Crater, scientists theorize that its frozen soil may contain the most significant discovery of humankind, life. On February 18, 2021, NASA's Perseverance rover started searching this crater to find out if we're truly alone. What is the likelihood of life on Mars? What would these Martians look like? And how will we send samples back to Earth? This is What If, and here's what would happen if we discovered life on Mars. As Scientific American puts it, it would take a near miracle for Mars to be sterile. Astrobiologist Chris McKay at NASA believes that Earth and Mars have been sharing materials for billions of years, kind of like using your roommate's spice rack. Comets or large meteorites that have hit Earth may have also sent debris onto Mars. A tiny fraction of this debris on Mars could have carried the same microbes that kick-started life as we know it on Earth. But what would this alien life look like? Many scientists agree that whatever life on Mars we might find would need to be incredibly robust. With a combination of radiation and freezing temperatures on Mars, could any life form survive such a harsh environment? As far-fetched as it sounds, microbiologists have discovered many organisms that thrive in extreme environments. The tardigrade, or water bear, is a highly resistant extremophile. It can withstand heat, cold, pressure, radiation, and even a complete lack of oxygen. There are also certain types of bacteria on Earth that rapidly produce spores when faced with hazardous conditions. The bacteria can then hibernate during an extended period of drought and withstand intense ionizing radiation. A team of 1,000 geologists, chemists, physicists, and biologists worldwide have drilled 4.8 kilometers into the Earth and discovered robust life forms. Mars has a similar geological past to Earth, so looking underground could be a great place to start. By drilling into Jezero Crater, we could encounter spores associated with a relatively recent geological era, and on future missions to Mars, we may dig deeper and uncover fully vegetative microbes. To find rock samples that might support life, NASA's Perseverance rover uses an array of lasers called a supercam. It can study the surface of Mars at a distance. One of the lasers will heat a rock sample and vaporize it, creating a plasma that can be analyzed to understand its elemental composition. Another laser will reveal which compounds are in the dirt. If the supercam detects organic molecules or elevated concentrations of elements like nitrogen or phosphorus, the rover will head over to take a closer look. It will then scan the soil in greater detail to detect any organic material hiding in the dirt. NASA's team on Earth has only one shot at picking the right spot to gather these samples. With limited space on board, the rover can only collect a few dozen samples, so no pressure and fingers crossed. If all goes well, NASA plans to bring back samples known for preserving biosignatures. On Earth, biosignatures are faint molecular traces left behind by microbes billions of years ago. Once the samples are collected, NASA and the European Space Agency plan 2 missions to get them back to Earth. This involves blasting tubes of rock and soil samples into orbit to be collected by another spacecraft, and then returned to Earth. This looks kind of fun. If Perseverance's mission is successful, the discovery of life on Mars would be as groundbreaking as the discovery of DNA in 1543. Copernicus boldly shook the status quo with his theory that the planets orbited the Sun. His discoveries completely changed our worldview, no longer putting Earth at the center of the universe. Discovering life beyond Earth could be just as powerful. But not finding any life could raise more questions. Is Earth truly special? Are we alone out here? Even if we don't discover life, these Martian rock samples will allow chemists to study the geochemistry, mineralogy, and foundational bedrock materials of Mars in detail. This could provide us with essential insights into the climate history of Mars and help us better understand Earth's climate as well. In 1976, 2 Viking landers became the first spacecraft from Earth to touch down on Mars. They too probed for life in the Martian soil, and the results are still debated to this day. One experiment indicated that the Martian soil tested positive for metabolism. On Earth, this would almost certainly suggest the presence of life, but another related experiment found no trace of organic material whatsoever. While most scientists have not reconciled the conflicting results, the consensus is that there's no conclusive evidence of life on Mars. But several researchers disagree. Recent discoveries of terrestrial microorganisms surviving outside of the ISS indicate that life may be resilient enough for Mars. And methane in the Martian atmosphere could be a sign of microbial methanogens, a type of microorganism that produces a significant amount of methane. Stinky aliens, mind you. It's possible that life on Mars didn't have the right conditions to start at all, or maybe it died off from an extinction event similar to the asteroid that wiped out the dinosaurs. Or it's even possible that we might end up finding life that was accidentally brought to Mars by one of our many rovers. Let's hope this Perseverance mission doesn't turn into a $2.7 billion facepalm. Venus, one of the most fascinating and dangerous planets in our solar system, is filled with scorching temperatures, crushing atmospheric pressure, and acid rain. But despite these dangers, some people think it might be a better planet for humans to settle on than Mars. But why? And would a human settlement on Venus even be possible? Sit back as we take you on a 10,000-day journey of how humanity could populate this planet. Yeah, maybe day 1. Okay, not so fast. Before you set foot on Venus, we're going to have to run some extensive tests and gather more information about this planet first. We'll need to launch robotic missions and map it out and collect information about the environment. Luckily, we already have a bit of a head start on this. Since 1961, spacecraft have been flying by and profiling Venus. These missions measure things like the topography, atmospheric pressure, and the overall conditions of the planet. But there's still a lot to learn about the Venusian surface. It's been 30 years since the US has gone to Venus with a mission. That's Noam Eisenberg. He works for the Venus Exploration Analysis Group, a NASA community whose goal is to keep people updated on new information about Venus. In the 2020s and 2030s, Noam will be part of a satellite mission to Venus to help us understand and see more of the planet than ever before. But today, Noam's going to help us determine whether or not colonizing Venus is a good idea. You have to wear one or the other of several different science fiction hats in order to make this happen. Okay, let's put our hypothetical science fiction hats to the test and get started. Day 500. We've been trying to colonize Venus for a little over a year now, and the results have been, well, there's been a bit of trial and error going on with our astronauts. They keep going out to explore the surface of Venus but keep dying. Why? It's not clear that if you were immediately transported there, whether you would burn to death or be crushed to death first, but certainly both of those things would happen before you asphyxiated in the carbon dioxide atmosphere. Right, well, we probably should have listened to Noam a bit closer because it turns out the Venusian surface is incredibly dangerous. 3 reasons why Venus has one of the hottest surface temperatures of any planet, even hotter than Mercury. The surface temperature reaches 467 degrees Celsius. That's hot enough to melt lead or some unsuspecting astronauts. But let's say we somehow managed to build super heat-resistant astronaut suits. Well, you'd still be met with incredible pressure. The atmospheric pressure on Venus is equivalent to what you'd experience at a depth of 900 meters underwater. This would instantly crush any astronaut. It would also crush and destroy your spaceship as you land. And if you manage to avoid all that, which you won't, but let's say you do, you'll also have to deal with a corrosive atmosphere and acid rain. These conditions are powerful enough to destroy your equipment, and eventually melt your skin. Okay, I don't think this is going to work out. Let's jump ahead and try to terraform Venus to make it more like Earth. Day 1000, so we've been attempting to terraform Venus, and it's been a pretty tricky process. The first problem we need to solve would be the atmosphere. To make it similar to what we have on Earth, we need to eliminate the carbon dioxide and sulfuric clouds. In theory, we could introduce genetically engineered microorganisms that absorb carbon dioxide, but then there's the scorching temperature on Venus. Now, solving this could be done in multiple ways. One of them involves setting up solar shades in space. This would redirect the sun's rays so they don't hit Venus, which would reduce the solar radiation and cool the planet over time. This all sounds wicked cool from a science fiction perspective, But realistically, we're a couple hundred or thousands of years too early for any of this to be possible. Okay, this is really complicated. No, many ideas? The only way we could inhabit the surface of Venus is if we change Venus to be much more Earth-like than it is. And right now we don't have that technology, we don't have that ability, we don't have the resources. If we can terraform Venus, it'd be much easier to sort of re-terraform Earth and undo all the damage we've done here. And I don't even know how you would go about doing that. Think about that as a science fiction, science fantasy method, right? What if we humans could live somewhere outside of Earth, say the Moon? Obviously, we can't just pack our stuff and move there today. But what if we terraformed it, reshaped it into Earth's image? How long would it take us to turn our natural satellite into a habitable place? What would this Earth-Moon look like? Would this even be possible? This is what if, and here's what would happen if we terraformed the Moon. Wondering why we chose the Moon and not Mars? With water ice buried beneath its surface, the red planet seems to be the best candidate to serve as our second Earth. But with zero experience terraforming, we should consider colonizing our natural satellite first. It gets twice as much sunlight as Mars and it's just a 3-day trip from us. In short, it would take us less time and money to construct a decent Earth on our Moon. So how exactly do we engineer a habitable planet? Just to be clear, we're not talking about building a permanent Moon base. We'd go nuts and actually transform the Moon into an Earth, just a smaller one. For starters, we need to build an atmosphere, and here's the fun part. To do that, we need to bombard our Moon with 100 water ice comets. We'd find them flying all around the Earth. These comets would crash into the Moon's surface, filling its plains with water and dispersing carbon dioxide along with water vapor and a little bit of ammonia and methane. All these gases would gather near the surface, creating an atmosphere. The newly formed seas would reflect much more sunlight, making the Moon appear 5 times brighter when seen from Earth. These ice comets would also give the Moon momentum, making our satellite spin close to an Earth-like cycle. The more comets we batter into the Moon, the faster it would rotate. A lunar day would drop down from an incredible 28 Earth days to just 60 hours. Since our satellite wouldn't rotate on its axis at the same rate it orbits the Earth anymore, it would no longer be tidally locked to our planet. For Earth, this would mean we'd be able to see the dark side of the Moon, although it wouldn't be dark. But how do we save the newly built lunar atmosphere from being stripped away by solar winds? We'd have a couple of options. The first one is easy. The Moon's own rotation would generate a dynamo effect. That dynamo could awaken the Moon's once active magnetic field that would keep the atmosphere in place. If that doesn't work out, we'd have to place a gigantic shield in orbit. That shield would work as an artificial bow shock, making up for a missing magnetic field. When that's all sorted, we'd bring in genetically engineered plants suitable for growing on the Moon's stony ground. We'd also drop some algae that would release oxygen into the air. That would be the start of life on the Moon. Finally, after many decades of hard and costly work, we'd send the first human colony to settle down on the first man-made planet. The terraformed Moon would get very warm from greenhouse effects. It would be mostly cloudy too, and with tides as high as 20 meters, surfers might want to make the trip. Living on the Moon would be just like living in Florida but with 1/6 of the Earth's gravity. The Moon settlers would be able to jump as high as 3 meters off the ground, remaining in the air for 4 seconds. And if they were really fit and full of stamina, they'd be able to run across the Moon's lakes. This is because running on the water requires less muscle power if you do it in reduced gravity. Would you move to the Moon to experience all that? No human has ever been outside of our solar system, and only a few of us have actually left the Earth. Even those who blasted out of here in a rocket didn't go too far. There are billions upon billions of planets out there, but they're so far away it would take us a very long time to reach them. If we jumped into the fastest spacecraft ever built, it would take us over 70,000 years to get to our neighboring star system, Alpha Centauri. Even if we could accelerate a spaceship to 99% the speed of light, over 26,000 years would pass until we arrived at the center of our own galaxy, and another 2 million years until we set foot in the nearest neighbor, the Andromeda Galaxy. How could we go about expanding our civilization into space if we're so terribly slow? To become an intergalactic civilization, we need to break the speed limit of the universe. But for all we know, traveling at light speed is physically impossible, never mind outperforming it. The universe is enormous, possibly infinite, and our lifespans are miserably short to cover those kinds of distances even at near light speeds. But let your curiosity take over and imagine we were a civilization that could approach light speed and travel among stars. We'd start with Alpha Centauri, our neighboring star system. Who knows? Maybe the exoplanet orbiting this three-star system would turn out to be habitable. Then we'd push ourselves out further to discover the billions of other worlds. Not all of them would be suitable for us to settle in. In astronomy, a habitable world is a planet that is just the right distance from its sun-like star to be able to sustain liquid water. But the reality is humans require so much more than that. Atmosphere, gravity, temperature, they're all important. It's unlikely that we'd find another planet just like Earth. But we could build self-sustaining Earth-like biomes on our giant spaceships where humans could live for generations. Or we could terraform some rocky exoplanets. First, we'd harvest water from a few ice comets. Then we'd alter the planet's atmospheres to resemble Earth's, anything to be able to breathe in fresh air again. Even though space would be so accessible, people wouldn't travel around the universe much once the new colonies were established. Even at the speed of light, it would take generations to make a trip to the other side of the universe. Space is just too vast. Remember, in this new world, you'd get to travel among stars only if you were a part of a ship's crew, a colonist, or a space miner. We'd send robots to perform our intergalactic chores. Robots don't eat, sleep, or go to the bathroom. They can withstand high levels of radiation and extreme temperatures, all the things that would kill a human being. But if space travel is something you crave, consider pursuing a career as a postal carrier because the most reliable way to communicate might be through the mail. Surprised? Well, our satellites rely on radio waves to transmit information. Even though these waves travel just as fast as light, they lose their strength over long distances. It's like being too far away from your Wi-Fi router. If humanity did become an interstellar society, we humans would end up spread out across hundreds of light years of space. At least we'd give Earth a break and allow it to recover from our mistreatment. Are you ready for a new start? Are you sick and tired of Earth and all its problems? Well, here's your chance to start fresh by moving to Titan. Yeah, you heard me. Titan, Saturn's largest moon, could be your new home away from home. How would we power our new home? What would we eat, and how would we handle crime? This is what if, and here's what would happen if we colonized Titan. Even if you weren't 1.2 billion kilometers away from Earth, starting a community is extremely hard. Luckily for you, we're here to help you work out the kinks. You know, the first thing they teach you in real estate is location, location, location. And thankfully, Titan fits the bill. Titan is the most Earth-like place in our solar system because of its thick atmosphere and water on its surface. Of course, there are some differences you're going to have to get used to. Differences like Titan having 1.6 times the atmospheric pressure of Earth. That's the same pressure you'd feel diving about 5 meters down into the ocean. On the plus side, Titan has seasonal changes that would let you rock your new fall getup. And I hope you like it because on Titan, a season lasts about 7 Earth years. The main pull, however, is Titan's abundant supply of hydrocarbons. They could be used to build shelters and for energy sources. Okay. That was a good enough reason for us to set up shop here. But how exactly would we create our community? Well, the first step would be to send a fleet of smart robots to start prepping for human settlers. The robots could start constructing houses, buildings, and mines. Since Titan is filled with hydrocarbons such as methane and ethane, it makes sense to convert them into plastic and use them as building materials. As for powering the settlement, we'd have to cover about 10% of Titan's surface with solar panels. That's no small feat, but with a little elbow grease and scientific know-how, we could pull it off. Next, it's time to make ourselves at home. But what would life on Titan be like anyway? Well, first you're going to have to bundle up. The surface temperature on Titan is minus 179 degrees. Translation: it's really cold. We would need to build large domes with self-sustaining ecosystems for us to stay alive. Those self-sustaining ecosystems would provide us with food. We would take the lessons learned from the International Space Station on how to grow lettuce, peas, and radishes. These have all been successfully grown in their space garden and will help us to understand how low gravity affects plants. With less sunlight reaching Titan than our plants are used to, we need to add additional lighting to make our galactic greenhouse thrive. But what if vegetables weren't cutting it? What if you had a craving for a juicy, meaty Earth burger? Please subscribe my channel for upcoming video. Thanks for watching.